Thanks for coming back to our discussion of IFR conditions. We're working our way through the causes of IFR, and we're wrapping up with the last three types of ceilings, how ceilings form. And we went already through the definitions, but we're looking at cloud formation right now. And we're on the second one, which is mixing the air to saturation. We talked about cooling the air to saturation, and now we're looking at when you mix air, how do clouds form? And this is kind of complicated, but remember we said that with air, if it's rising and sinking, it'll rise and sink at the dry adiabatic lapse rate. So if you have strong winds in the layer, you'll have these eddies in the lowest layers of the atmosphere, in the boundary layer. And what happens is the air close to the ground rises at the dry adiabatic lapse rate, and the air at higher altitude will sink at the dry adiabatic lapse rate. So as a result, you get kind of an inversion. It's a little bit more stable. And then the dew point also changes. It becomes more uniform. In other words, it mixes out through the depth of the atmosphere, and it gets closer to the temperature lapse rate. So when that happens, you'll notice that clouds start to form through mixing. And the kind of clouds that you get are stratocumulus. Now, this happens all the time here in North Dakota. Usually after a cold front goes through, we still have a little bit of moisture. Not a lot, but we still have a little bit of moisture. And the winds are pretty strong behind a cold front, so they mix up the lowest layers of the atmosphere. You start getting turbulence. And you'll get this layer of clouds, typically anywhere from 1,000 to 2,000 feet, maybe a little bit higher, 2,500 feet AGL. They're not usually very thick. They're usually only about 500, maybe 1,000 feet thick. These are stratocumulus clouds. Stratocumulus clouds are flat, so they're stratus, but they have lots of bumps in them, so they're cumulus. That's what stratocumulus clouds look like. I think I've got better pictures and I need to replace this one, but that's the best I can do. And it's your typical kind of gray wintertime clouds. They happen also in the spring and in the fall, and sometimes even in the summer you'll see them. But they happen when there's strong mixing in the boundary layer. You get kind of a lower layer of clouds that are stratocumulus. Another way that clouds form is by adding moisture through precipitation. This typically happens when precipitation is falling out of a cloud, and as it falls into the drier air, it starts to evaporate. So it's adding moisture to the lower layer of air. And that evaporation starts increasing the dew point in the lowest layers. And when the dew point increases to reach the temperature, you get the formation of lower clouds. So this is very common, where you see clouds form at lower altitudes and perhaps eventually merge with the upper level clouds. So this typically happens when you have a subsaturated environmental air down low. In other words, the air has not reached the dew point, but you have precipitation falling into it. And then finally, the last way that clouds can form is when fog lifts. So you may have some fog in the early morning hours, as this represents. You can see the dark black sky and the white fog down low. But as the sun rises, the radiation actually does make it through, the solar radiation makes it through the fog to the surface of the Earth. The surface of the Earth starts heating up and starts to evaporate the water droplets closest to the ground. And that manifests itself as a cloud that rises. So it looks like it's actually rising, but it's just the evaporation that's occurring. Those are the four main methods by which clouds form.